Vitamin, Wikipedia audio. A vitamin is an organic compound and an essential nutrient that an organism requires in limited amounts. An organic chemical compound is called a vitamin when the organism cannot make the compound in sufficient quantities, and it must be obtained through the diet. Thus, the term vitamin is conditional upon the circumstances and the particular organism. For example, vitamin C is a vitamin for humans, but not most other animals which make enough internally. Vitamin D is essential only for people who do not have adequate skin exposure to sunlight, because the ultraviolet light in sunlight normally promotes synthesis of vitamin D. While vitamin supplements are important for the treatment of certain health problems, otherwise healthy people generally receive no benefit from using vitamin supplements. By convention, the word vitamin does not include other essential nutrients, such as dietary minerals, essential fatty acids and essential amino acids. 13 vitamins are universally recognized at present. Vitamins are classified by both biological and chemical activity, and not their structure. Each vitamin name refers to a number of vitamer compounds that all show the same biological activity. For example, vitamin A refers to the compounds retinol, retinol, and 4 known carotenoids. Vitamers by definition are convertible to the active form of the vitamin in the body, and are sometimes interconvertible to one another as well. Vitamins have diverse biochemical functions. Some, such as vitamin D, have hormone-like functions as regulators of mineral metabolism, or regulators of cell and tissue growth and differentiation. Others function as antioxidants. The largest number of vitamins, the B-complex vitamins, function as enzyme cofactors or the precursors for them. Coenzymes help enzymes in their work as catalysts in metabolism. In this role, vitamins may be tightly bound to enzymes as part of prosthetic groups. For example, biotin is part of enzymes involved in making fatty acids. They may also be less tightly bound to enzyme catalysts as coenzymes, detachable molecules that function to carry chemical groups or electrons between molecules. For example, folic acid may carry methyl, formyl, and methylene groups in the cell. Although these roles in assisting enzyme-substrate reactions are vitamins' best known function, the other vitamin functions are equally important. List of vitamins. Until the mid-1930s, when the first commercial yeast extract vitamin B complex and semi-synthetic vitamin C supplement tablets were sold, vitamins were obtained solely through food intake, and changes in diet usually greatly altered the types and amounts of vitamins ingested. However, vitamins have been produced as commodity chemicals and made widely available as inexpensive semi-synthetic and synthetic source multivitamin dietary and food supplements and additives, since the middle of the 20th century. Study of structural activity, function, and their role in maintaining health is called vitaminology. Each vitamin is typically used in multiple reactions, and therefore most have multiple functions. Vitamins are essential for the normal growth and development of a multicellular organism. Using the genetic blueprint inherited from its parents, a fetus begins to develop from the nutrients it absorbs. It requires certain vitamins and minerals to be present at certain times. These nutrients facilitate the chemical reactions that produce, among other things, skin, bone, and muscle. If there is serious deficiency in one or more of these nutrients, a child may develop a deficiency disease. Even minor deficiencies may cause permanent damage. For the most part, vitamins are obtained with food, but a few are obtained by other means. For example, microorganisms in the intestine commonly known as gut flora produce vitamin K and biotin, while one form of vitamin D is synthesized in the skin with the help of the natural ultraviolet wavelength of sunlight. Humans can produce some vitamins from precursors they consume. Examples include vitamin A, produced from beta-carotene, and niacin, from the amino acid tryptophan. Once growth and development are completed, vitamins remain essential nutrients for the healthy maintenance of the cells, tissues, and organs that make up a multicellular organism. They also enable a multicellular life form to efficiently use chemical energy provided by food it eats, and to help process the proteins, carbohydrates, and fats required for cellular respiration. In those who are otherwise healthy, there is little evidence that supplements have any benefits with respect to cancer or heart disease. Vitamin A and E supplements not only provide no health benefits for generally healthy individuals, but they may increase mortality, though the two large studies that support this conclusion included smokers for whom it was already known that beta-carotene supplements can be harmful. Other findings suggest that vitamin E toxicity is limited to only a specific form when taken in excess. The European Union and other countries of Europe have regulations that define limits of vitamin dosages for their safe use as dietary supplements. Most vitamins that are sold as dietary supplements are not supposed to exceed a maximum daily dosage referred to as the tolerable upper intake level. Vitamin products above these regulatory limits are not considered supplements and should be registered as prescription or non-prescription due to their potential side effects. The European Union, United States, Japan, and some other countries each set rules. Dietary supplements often contain vitamins, but may also include other ingredients, such as minerals, herbs, and botanicals. Scientific evidence supports the benefits of dietary supplements for persons with certain health conditions. In some cases, vitamin supplements may have unwanted effects, especially if taken before surgery, with other dietary supplements or medicines, or if the person taking them has certain health conditions. They may also contain levels of vitamins many times higher, and in different forms, than one may ingest through food. The USDA has conducted extensive studies on the percentage losses of various nutrients from different food types and cooking methods. Health effects. Some vitamins may become more bioavailable, that is, usable by the body when foods are cooked. The table below shows whether various vitamins are susceptible to loss from heat, such as heat from boiling, steaming, frying, etc. The effect of cutting vegetables can be seen from exposure to air and light. Water-soluble vitamins such as B and C dissolve into the water when a vegetable is boiled, and are then lost when the water is discarded. Humans must consume vitamins periodically but with differing schedules, to avoid deficiency. The body's stores for different vitamins vary widely. Vitamins A, D, and B12 are stored in significant amounts, mainly in the liver, and an adult's diet may be deficient in vitamins A and D for many months and B12 in some cases for years, before developing a deficiency condition. However, vitamin B3 is not stored in significant amounts, so stores may last only a couple of weeks. For vitamin C, the first symptoms of scurvy in experimental studies of complete vitamin C deprivation in humans have varied widely, from a month to more than 6 months, depending on previous dietary history that determined body stores. Deficiencies of vitamins are classified as either primary or secondary. A primary deficiency occurs when an organism does not get enough of the vitamin in its food. A secondary deficiency may be due to an underlying disorder that prevents or limits the absorption or use of the vitamin, due to a lifestyle factor, such as smoking, excessive alcohol consumption, or the use of medications that interfere with the absorption or use of the vitamin. People who eat a varied diet are unlikely to develop a severe primary vitamin deficiency. In contrast, restrictive diets have the potential to cause prolonged vitamin deficits, which may result in often painful and potentially deadly diseases. Well-known human vitamin deficiencies involve thiamine, niacin, vitamin C, and vitamin D. In much of the developed world, such deficiencies are rare. This is due to an adequate supply of food and the addition of vitamins and minerals to common foods. In addition to these classical vitamin deficiency diseases, some evidence has also suggested links between vitamin deficiency and a number of different disorders. Some vitamins have documented side effects that tend to be more severe with a larger dosage. The likelihood of consuming too much of any vitamin from food is remote, but overdosing from vitamin supplementation does occur. Acute symptoms can include nausea, vomiting and diarrhea. In the United States, the Institute of Medicine of the National Academies has established tolerable upper intake levels for those vitamins which have documented side effects at high intakes. In the European Union, the European Food Safety Authority has also set ULs. ULs from the two organizations do not always match. In 2014, overdose exposure to all formulations of vitamins and multivitamin/mineral formulations was reported by 68,058 individuals to the American Association of Poison Control Centers, with 73% of these exposures in children under the age of 5. Supplements. Effect of cooking. Vitamins are classified as either water-soluble or fat-soluble. In humans there are 13 vitamins, 4 fat-soluble and 9 water-soluble. Water-soluble vitamins dissolve easily in water and, in general, are readily excreted from the body, to the degree that urinary output is a strong predictor of vitamin consumption. Because they are not as readily stored, more consistent intake is important. Fat-soluble vitamins are absorbed through the intestinal tract with the help of lipids. Because they are more likely to accumulate in the body, they are more likely to lead to hypervitaminosis than are water-soluble vitamins. Fat-soluble vitamin regulation is of particular significance in cystic fibrosis. Deficiencies. Hypervitaminosis. Pharmacology. History. Etymology. The value of eating a certain food to maintain health was recognized long before vitamins were identified. The ancient Egyptians knew that feeding liver to a person may help with night blindness, an illness now known to be caused by a vitamin A deficiency. The advancement of ocean voyages during the Renaissance resulted in prolonged periods without access to fresh fruits and vegetables, and made illnesses from vitamin deficiency common among ships' crews. In 1747, the Scottish surgeon James Lind discovered that citrus foods helped prevent scurvy, a particularly deadly disease in which collagen is not properly formed, causing poor wound healing, bleeding of the gums, severe pain, and death. In 1753, Lind published his treatise on the scurvy, which recommended using lemons and limes to avoid scurvy, which was adopted by the British Royal Navy. This led to the nickname limey for British sailors. Lind's discovery, however, was not widely accepted by individuals in the Royal Navy's Arctic expeditions in the 19th century, where it was widely believed that scurvy could be prevented by practicing good hygiene, regular exercise, and maintaining the morale of the crew while on board, rather than by a diet of fresh food. As a result, Arctic expeditions continued to be plagued by scurvy and other deficiency diseases. In the early 20th century, when Robert Falcon Scott made his 2 expeditions to the Antarctic, the prevailing medical theory at the time was that scurvy was caused by tainted canned food. During the late 18th and early 19th centuries, the use of deprivation studies allowed scientists to isolate and identify a number of vitamins. Lipid from fish oil was used to cure rickets in rats, and the fat-soluble nutrient was called antirachitic A. Thus, the first vitamin bioactivity ever isolated, which cured rickets, was initially called vitamin A. However, the bioactivity of this compound is now called vitamin D. In 1881, Russian surgeon Nikolai Lunin studied the effects of scurvy at the University of Tartu in present-day Estonia. He fed mice an artificial mixture of all the separate constituents of milk known at that time, namely the proteins, fats, carbohydrates, and salts. The mice that received only the individual constituents died, while the mice fed by milk itself developed normally. He made a conclusion that a natural food such as milk must therefore contain, besides these known principal ingredients, small quantities of unknown substances essential to life. However, his conclusions were rejected by his advisor, Gustav von Bungay, even after other students reproduced his results. A similar result by Cornelius Peckel-Haring appeared in a Dutch medical journal in 1905, but it was not widely reported. Society and culture. In East Asia, where polished white rice was the common staple food of the middle class, beriberi resulting from lack of vitamin B1 was endemic. In 1884, Takaki Kanehiro, a British-trained medical doctor of the Imperial Japanese Navy, observed that beriberi was endemic among low-ranking crew who often ate nothing but rice, but not among officers who consumed a Western-style diet. With the support of the Japanese Navy, he experimented using crews of 2 battleships. One crew was fed only white rice, while the other was fed a diet of meat, fish, barley, rice, and beans. The group that ate only white rice documented 161 crew members with beriberi and 25 deaths, while the latter group had only 14 cases of beriberi and no deaths. This convinced Takaki and the Japanese Navy that diet was the cause of beriberi, but they mistakenly believed that sufficient amounts of protein prevented it. That diseases could result from some dietary deficiencies was further investigated by Christian Eichmann, who in 1897 discovered that feeding unpolished rice instead of the polished variety to chickens helped to prevent beriberi in the chickens. The following year, Frederick Hopkins postulated that some foods contained accessory factors in addition to proteins, carbohydrates, fats etc. that are necessary for the functions of the human body. Hopkins and Eichmann were awarded the Nobel Prize for Physiology or Medicine in 1929 for their discoveries. In 1910, the first vitamin complex was isolated by Japanese scientist Umataro Suzuki, who succeeded in extracting a water-soluble complex of micronutrients from rice bran and named it obaric acid. He published this discovery in a Japanese scientific journal. When the article was translated into German, the translation failed to state that it was a newly discovered nutrient, a claim made in the original Japanese article, and hence his discovery failed to gain publicity. In 1912, Polish-born biochemist Casimir Funk, working in London, isolated the same complex of micronutrients and proposed the complex be named vitamin. It was later to be known as vitamin B3, though he described it as anti-beriberi factor. Funk proposed the hypothesis that other diseases, such as rickets, pellagra, celiac disease, and scurvy could also be cured by vitamins. Max Nierenstein, a friend and reader of biochemistry at Bristol University, reportedly suggested the vitamin name. The name soon became synonymous with Hopkins' accessory factors, and, by the time it was shown that not all vitamins are amines, the word was already ubiquitous. In 1920, Jack Cecil Drummond proposed that the final E be dropped to de-emphasize the amine reference, after researchers began to suspect that not all vitamins have an amine component. In 1930, Paul Karrer elucidated the correct structure for beta-carotene, the main precursor of vitamin A, and identified other carotenoids. Karrer and Norman Hayworth confirmed Albert Szent-György's discovery of ascorbic acid and made significant contributions to the chemistry of flavins, which led to the identification of lactoflavin. For their investigations on carotenoids, flavins, and vitamins A and B2, they both received the Nobel Prize in Chemistry in 1937. In 1931, Albert Szent-Györgyi and a fellow researcher Joseph Sverbely suspected that hexuronic acid was actually vitamin C, and gave a sample to Charles Glenn King, who proved its anti-scorbutic activity in his long-established guinea pig scorbutic assay. In 1937, Szent-Györgyi was awarded the Nobel Prize in Physiology or Medicine for his discovery. In 1943, Edward Adalbert Doisy and Henrik Dam were awarded the Nobel Prize in Physiology or Medicine for their discovery of vitamin K and its chemical structure. In 1967, George Wald was awarded the Nobel Prize for his discovery that vitamin A could participate directly in a physiological process. The term vitamin was derived from vitamin, a compound word coined in 1912 by the Polish biochemist Kazimierz Funk when working at the Lister Institute of Preventive Medicine. The name is from vital and amine, meaning amine of life, because it was suggested in 1912 that the organic micronutrient food factors that prevent beriberi and perhaps other similar dietary deficiency diseases might be chemical amines. This was true of thiamine, but after it was found that other such micronutrients were not amines, the word was shortened to vitamin in English. Once discovered, vitamins were actively promoted in articles and advertisements in McCall's, Good Housekeeping, and other media outlets. Marketers enthusiastically promoted cod liver oil, a source of vitamin D, as bottled sunshine, and bananas as a natural vitality food. They promoted foods such as yeast cakes, a source of B vitamins, on the basis of scientifically determined nutritional value, rather than taste or appearance. World War II researchers focused on the need to ensure adequate nutrition, especially in processed foods. Robert W. Yoder is credited with first using the term vitamania, in 1942, to describe the appeal of relying on nutritional supplements rather than on obtaining vitamins from a varied diet of foods. The continuing preoccupation with a healthy lifestyle has led to an obsessive consumption of additives, the beneficial effects of which are questionable. Most countries place dietary supplements in a special category under the general umbrella of foods, not drugs. As a result, the manufacturer, and not the government, has the responsibility of ensuring that its dietary supplement products are safe before they are marketed. Regulation of supplements varies widely by country. In the United States, a dietary supplement is defined under the Dietary Supplement Health and Education Act of 1994. There is no FDA approval process for dietary supplements, and no requirement that manufacturers prove the safety or efficacy of supplements introduced before 1994. The Food and Drug Administration must rely on its adverse event reporting system to monitor adverse events that occur with supplements. In 2007, the U.S. Code of Federal Regulations Title 21, Part 3 took effect, regulating good manufacturing practices in the manufacturing, packaging, labeling, or holding operations for dietary supplements. Even though product registration is not required, these regulations mandate production and quality control standards for dietary supplements. In the European Union, the Food Supplements Directive requires that only those supplements that have been proven safe can be sold without a prescription. For most vitamins, pharmacopoeia standards have been established. In the United States, the United States Pharmacopoeia sets standards for the most commonly used vitamins and preparations thereof. Likewise, monographs of the European Pharmacopoeia regulate aspects of identity and purity for vitamins on the European market. Governmental regulation. The reason that the set of vitamins skips directly from E to K is that the vitamins corresponding to letters FJ were either reclassified over time, discarded as false leads, or renamed because of their relationship to vitamin B, which became a complex of vitamins. The German-speaking scientists who isolated and described vitamin K did so because the vitamin is intimately involved in the coagulation of blood following wounding. At the time, most of the letters from F through to J were already designated, so the use of the letter K was considered quite reasonable. The table nomenclature of reclassified vitamins lists chemicals that had previously been classified as vitamins, as well as the earlier names of vitamins that later became part of the B complex. Naming. There are other missing B vitamins which were reclassified or determined not to be vitamins. For example, B9 is folic acid and 5 of the folates are in the range B11 through B16, forms of other vitamins already discovered, not required as a nutrient by the entire population, biologically inactive, toxic, or with unclassifiable effects in humans, or not generally recognized as vitamins by science, such as the highest numbered, which some naturopath practitioners call B21 and B22. There are also 9-lettered B complex vitamins. There are other D vitamins now recognized as other substances, which some sources of the same type number up to D7. The controversial cancer treatment Laetrile was at one point lettered as vitamin B17. There appears to be no consensus on any vitamins Q, R, T, V, W, X, Y, or Z, nor are there substances officially designated as vitamins N or I, although the latter may have been another form of one of the other vitamins or a known and named nutrient of another type. Antivitamins are chemical compounds that inhibit the absorption or actions of vitamins. For example, avidin is a protein in raw egg whites that inhibits the absorption of biotin. It is deactivated by cooking. Pyrithiamine, a synthetic compound, has a molecular structure similar to thiamine, vitamin B1, and inhibits the enzymes that use thiamine. Antivitamins.